Here are a couple of additional examples if you're still struggling maybe with how do I use log properties in order to solve log equations, right? So I'm just going to go through a couple more examples to help you to maybe see how these properties are used. Okay, so this first example, again, we have a log property. I'm sorry, let's start with this. The ideal situation is log on the left equals log on the right, and that lets us set what's inside of the logs equal to each other. So we're trying to get to this situation right here. If I'm looking at my problem, I do have one log on the right, that's good, but I have two logs on the left. And I don't want there to be two logs on the left. That kind of messes up my situation. So I'm going to look at this and say, how can I use log properties to combine these log base 2's on the left-hand side so there's only one of them? So in order to do that in this case, I'm going to use the property that says if there is subtraction between logs, you're allowed to combine them into one log as long as you divide what's inside of the log. So in this case, I'm going to say x plus 4 can be divided with x minus 5, right? And that's going to be my one log, right? So here's my problem. Now I have my ideal situation. Log on the left, log on the right, equation between them. That means that I can just drop the logs off the problem and say what's inside of the logs, x plus 4 over x minus 5, has to be equal to 10. And how you choose to handle this one is just up to what kind of your perspective. I like to look at it as a proportion. If I cross multiply, this is going to look like 10x minus 50 is equal to x plus 4. And then let's solve. So I'm going to add the 50 over, and it's going to become a 54. I'm going to subtract this x back, and it's going to become 9x. So it looks like x has to be equal to 6. Right? I'm just going to do a quick check. This is my answer. Okay. If I plug in my log here, it becomes 6 plus 4, which is 10. That's fine. I can take the log of a positive 10. And when I plug it in right here, I get 6 minus 5, which is 1. That also works. I can take the log of a positive 1. So this 6 that we're saying is our solution is good. It is not extraneous. I'm allowed to use it. Okay. So I want to show you a problem that's going to work out very similar to this, but with one slight adjustment, just so you can again see this the slight difference between these problems. Okay. So in this problem, same kind of situation. I have a minus sign in between these two logs on the left, so let's put those together right now. This says the log base 4, and because there's subtraction in between the two logs, I'm going to divide what's inside of the logs. X plus 3 over x minus 1. Okay. So there's my combination. This equals 2. Okay. So what some people want to do at this point is to set x plus 3 over x minus 1 equal to 2. Okay. And that is not true in this case. Okay. It's only true if the right-hand side also has its own log, right? If you take a look at this problem, I didn't take just 10. It was the log of 10. That's what let me use the property. In this second example here, I do not have that happening. I just have a regular old 2. So when this problem occurs, you're just going to look at this and say, base, exponent, this is what should come out of that problem, right? So remember back to the fact that of what a log was, and when we originally did log conversions, how we did those, that's what's going on in this case. So I'm going to say in this case that x plus 3 over x minus 1 is equal to 4 to the second power, doing my log conversion. So this is really 16. Again, it's over 1, so it's going to be 16 times x minus 1, which is 16x minus 16, and that equals x plus 3. So again, I'll solve this one, and I get, it looks like 15x is equal to 19, and so not a really nice answer, 19 over 15. That is my solution, right? And I'm going to check the problem. Taking a positive fraction and adding to it, it's going to stay positive. I don't even care what it is. I just know it's positive. That's good, okay? Taking this value and subtracting 1 is still going to keep it positive, and I know that because 19 over 15 is bigger than 1, so it's going to not be positive. It'll be some small fraction or decimal, but still a positive number, okay? So just these two contrasting problems, again, highlighting the different situations you might come into. One of them used the one-to-one property. The other one used what we know about just log conversions to exponential form. In both cases, though, we did have to use a property of log in order to simplify it down to a place where I could use either of those two methods in order to solve. So your log properties will be really important. You're going to have to use them in order to solve a lot of different log problems.